Algebra Unit 6, Lesson 8, Systems of Inequalities Applications. Video and Notes 11. Letter A. Is 3, negative 6 a solution to the system? Y is less than or equal to negative 2x, and y is greater than 3 times the quantity x minus 5. So, multiple ways to do this. One would be we ignore the question for a moment and just focus on the inequalities, graph the two, and see if this falls into where we place the s. That's a lot of work. We're not given graphs, so let's not do that. Let's think about the shortcut here. If this is a solution to these two inequalities, then both should make sense when we substitute or plug the values in. So I'm going to start by doing that. So the first inequality is y is less than or equal to negative 2x. So I'm going to replace all of that with these values. So instead of y, negative 6 is less than or equal to negative 2 times what x is, 3. Now do the math. Negative 6 is less than or equal to negative 6. Is that true? Is negative 6 less than or equal to negative 6? Yes, it is. So the first one is true, but we have to try both. The second one, y is greater than. So negative 6 is greater than. Again, I'm just using my ordered pair there. 3 times the quantity x minus 5. And again, x is now 3. Again, do the math. In case you're forgetting, this is a distribution problem. Or we could follow the order of operations and get 3 times negative 2. But no, again, no matter which way you do it, you get negative 6. And then here's our question. Is that a true statement, a true sentence? Negative 6 is greater than negative 6. No, negative 6 is exactly the same. This is not true, therefore this is not a solution. Letter B, same idea. Take your ordered pair, plug it into both 1, 2 inequalities, and solve. Now, if you make any minor mathematical errors, multiplying, adding, anything, you're going to be wrong. And all of this, taking this ordered pair and plugging it in into these two inequalities, is way back 5th and 6th grade material. So take your time and honestly do the problem. When you're done, you should get yes. Now, just writing down yes doesn't help you at all. So do the problem. Letter C. The next set of A and B. We're going to do A together. I'm going to let you do B on your own. Notice already that B is not in slope-intercept form. So before we can graph, we always have to do that. Back to letter A. Find the solution set to each system graphically. So we can use a calculator to assist, of course, but our answer has to be done graphically. So we have to use the graph. I'm going to start and do what I think is the easiest one. Y is greater than or equal to 0. Now, most students struggle with this one because you forget kind of the easier steps and go right to the hard stuff. So I'm going to first identify that here is the y-axis. We know that. We can never forget that. Where is y 0? Okay, well, here's y is 9, 8, 7, continuing down. Here is where y is 0. So that's my line. Because of this symbol, again, I have a solid line. So I'm going to go back and erase all those and draw that line. So it's a solid line where y is 0. Okay, so my line is drawn. My next step is, okay, this is not an equation. So I don't have a line. I have a region of space or a bunch of stuff, many, infinite solutions here. So I'm going back to this idea, y is greater than or equal to 0. So where are numbers greater than 0? We already know where it's equal to. We already drew the line. So what numbers, just think logically, what numbers are greater than 0? 1, 2, 10, 100. So where are those on this graph? Well, they're up here. And again, your shading is not pretty. It's just shading so you can see values. So if you're spending time doing this, you're wasting time. And we don't have time for that. Okay, done. I'm now going to move on to another inequality. So I again do the next easiest. So y is less than or equal to x plus 4. So y equals mx plus b. I begin at the y-intercept and I move with the slope. So my first point is at positive 4. And again, if colors help you, go ahead and use colored pencils for this. However, don't rely on them to help you forever because the Regents exam won't allow you to use colored pencils. So it's kind of your choice. Take the time and use colored pencils to really hone in on your skills here and understand and see where the shaded boundaries meet, or shade vertically in one section, horizontally in another, and then diagonal in the third. So my first point is at positive 4, which I put. My slope then, if it's x, it's 1x or 1 over 1. So then I'm going to count up 1 over 1, up 1 over 1, and I'm going to make my graph again long and clearly through the whole graph. I'm going to use a ruler again, and with this symbol, we know again it's a solid line. Your line should look like that. I'm also going to remember here, maybe now that I have 2 lines, that I need to label each one. And as I do that, that helps me to go back and check to see if I have any mistakes or errors. It's also a way not to lose points. So with this one, I need to know where y is less than or equal to, so I'm shading below. So below this line would be down here. Again, my shading's not pretty. It's just getting the job done. So far, I can clearly see that if I was done, the solution would be where both of those 2 colors are on top of each other, where the shaded regions are mixing or crossing. But I'm not done. I do have one more. So the last inequality is this one here. Now this is not in slope-intercept form, so I'm going to start by moving it to make it be. So y is less than or equal to, I see a negative 1x or negative slope, and I see a positive 4 or positive y-intercept, which means I'm starting again at positive 4. But this time my slope is down 1 over 1, so it's a negative line. Again, take the time to make it long and extensive, cover the whole graph. Due to it being less than or equal to, I know that it is a solid line, so go ahead and draw that one. So I went ahead and connected the dots, made it a nice straight line with my ruler. I labeled the line. I have arrowheads on both ends. It's extensively covering the full graph. So now I'm just looking, okay, where do I need to shade this? Well, it's, again, y is less than or equal to, so I need to shade below the line. So below in this case would be down here. So now I need to look and see where are all 3 colors. Well, here is just blue and red. Here is blue and green. Here is red and green. Here is just red. But right in the middle here is red, blue, and green. Now maybe you realize, oh, I didn't shade very well, so maybe you just come back and add some more red lines so you can see it more easily. We're going to label that center point where the solution is, again with that capital S. Shading is not beautiful, so please don't spend your time doing that. Do what you need to so you can visually see the problem. Please try B on your own. Okay, when you're finished B, then we're moving on to this third section, letter D, and we have 2 sample problems here. Write the system of inequalities that represents the graph below. I think I'm going to let you do A on your own because I feel like that one is much more reasonable. We'll do B together. This blue point here is just saying there's a solution there, so we don't even need to really worry about that. We would label that instead as a big S. Okay, notice we have a dotted and a solid line, so take that into account. We're going to go over and do letter B. So that one is definitely more difficult. Letter B is, okay, so I'm just looking at it. I see a triangle shaded. So if I see a triangle, I need to think back, well, if I have a triangle, then I have to have 3 lines or 3 sides. If I have 3 sides, that means I need 3 inequalities. So at the end, maybe it kind of should look like letter C. There is a triangle with 3 lines. All right, so I'm going to start with maybe, again, what I appear to think is the easiest. I see that this is a boundary end right here. So I need to know, well, what line is that? Well, we're going to start with our slope-intercept form, so y. This one is shaded above, clearly above, so it's greater than. It's a solid line, so it's greater than or equal to. And what position on the y-axis is that? Well, that's at 0. So my first inequality is y is greater than or equal to 0. All right, next line I'm going to look at. Again, it doesn't really matter. I think I'm going to do this one next. I see that first it's a negative slope. Okay, so I'm going to need to have then a negative something, meaning the slope. I need to find the y-intercept. So I'm going to start and look there, and that is at positive 4. So now I have a few pieces done. I know I need an x, so now I'm looking for the slope. So the slope is found by the change in y over the change in x, or the rise and the run. So I'm going to go in here and kind of look at this. I have an exact point right there. My green line's a little bit off, but there's another exact point. There's another. And if I look really closely, actually, these are all perfect, which means we're falling, running, falling, running, falling, running. It looks like my slope is negative 1 over 1, or just negative x. So after doing that, I have y something, negative x plus 4. So I need to know where are we shaded? So again, we're talking about this line, and it looks like the shading is down here, which then tells us that y should be shading below or less than. It's a solid line, or equal to. So y is less than or equal to. And now we need the third line. The only one we haven't really discussed yet is this steeper sloped of a line. Okay, so I'm going to start by, again, maybe this time I start a little bit differently. I'll do the y-intercept at the very beginning. Oh, it's still positive 4. Okay, now I'm going to count the slope. So now again, I'm focusing on this line here. Not a perfect point, not a perfect point. Oh, there's a perfect point. And if I keep going down, there's another perfect point. So I need to calculate my rise and my run, or in this case it's negative again, so my fall in my run. 1, 2, 3, 4, 1. So it looks like it's 4 over 1, and because it's negative 4 over 1. Now, 4 over 1 is a lot of work. I'm just going to write negative 4x. And then we need to start with our y. So this line here then, it's definitely not shaded below, so it's shaded above. And above means greater than, and it's a solid line, or equal to. So our final answer for letter B is that we have the system of inequalities. Y is greater than or equal to 0, y is less than or equal to negative x plus 4, and y is greater than or equal to negative 4x plus 4. Again, I'd like you to go back and do letter A on your own. You should only have 2 inequalities, as there's no shape drawn here. It's just a shaded region or shaded zone. Good luck. On the next page, we'll start some applications or word problems. Edith babysits for X hours a week. This is good. It's already identified. It means I probably don't need let statements. X hours a week after school at a job that pays $4 an hour. So here's my first money question, or money portion. She accepts a job that pays $8 an hour. And there's a second money information piece. As a library assistant working Y hours, there's my second variable, a week. She will work both jobs. Okay, so she's going to do both things. She's able to work no more than 15 hours a week. So that piece of information, first of all, it's talking about hours, but no more than 15. So maybe in my head right now, I just think a little bit, no more than 15. So no more than 15. Can she work 6 hours? Yes, because it's no more than, it's not bigger than 15. Can she work 35 hours? No, because 35 hours is more than. So what she's working needs to be less than 15 or equal to 15, because she cannot work 15, okay, due to school commitments. Otherwise, her homework and her grades may fall behind. Edith wants to earn at least $80. So there's my third portion of the money. So I'm just going to circle that one in blue again. At least $80. So again, think through that and make it make sense to you. At least $80. Can she make 80? Yes. Can she make 70? No, because at least 80 is greater than 80. It's more than 80. So here I need a greater than symbol, or equal to. And over here, no more than 15, I need a less than or equal to. So now we're just going to put all that together. Anything with money is one inequality, and anything with numbers of hours is the other. So it sounds like she's working both jobs. She actually has to work both jobs. So my first inequality then is x plus y, no more than 15 hours. So again, we said she can work 6, she can work 15, but 35 is out of the question. 35 is not less than 15. So again, if you're reading this and literally gisting this paragraph, this question, just like you do in ELA or social studies, you're going to do better. You can't just read it and say, I'm stuck, I don't get it. You have to think through these problems. The second one, now we're talking about money. She has to work both jobs. Well, she's going to work babysitting, so she gets $4 each every per, so $4 an hour. And she's working the other job, and she gets $8 per hour. And she needs to earn at least $80. So she's setting a goal. Maybe she wants to buy something, but she must earn at least $80. So slowing down, reading, and understanding the problem is going to make the writing of the inequalities much simpler for you. Now that we have those, letter B, graph these inequalities on the set of axes below. Okay. Before we can ever graph, we need our slope-intercept form. So we need to change these or translate these. So this is a great time for you to pause the video and practice this again on your own. Practice makes perfect. Solving equations and inequalities should now be a habit for you. It shouldn't be tricky or difficult. And if it is, again, you need to put in more practice. So pause the video. When you press play, I'll have the answers for you. Your two inequalities should be what mine are here. Now we're going to go ahead and graph those. Notice the x-axis and y-axis are already labeled for you. They're already counting by ones or units of ones, but we only marked the 10 and 20. So I'm thinking the rest of this problem you can do on your own. Remember, do we need solid or dotted lines? Remember, we have to shade. Okay, letter C. Determine and state one combination of hours that will allow Edith to earn at least $80 per week while working no more than 15 hours. Again, this one I think you can do on your own. So when you graph it, you graph one inequality, you label the line, dotted or solid, arrowheads, shade. Do the same with the second one. Where those two shaded regions cross or intersect or overlap is where you put the capital S, it's the solution. Letter C is asking, tell me one point that is in that solution and explain it to me in a nice 8th to 9th grade sentence. Tell me about it. Don't say an ordered pair. Say Edith can work blank hours babysitting and blank hours at the library in a week. Okay, letter F. Eric is participating in a running and biking fundraising event. For the event, he can travel no more than 16 miles. Eric must bike at least 4 miles and run no more than 2 miles. Writing a system of inequalities for the number of miles Eric bikes, X, and the number of miles Eric runs, Y. Great. We don't need let statements here. They're done for us. All right, I'm going to start with what I think is the easiest inequality. Again, it's my personal preference, and hopefully as you get through these, you're going to have preferences of where you want to start, and hopefully you'll get more comfortable. For the event, he can travel no more than 16 miles. Well, I know he has to do both. X is biking and Y is running, so he has to do both, so that means he's going to be biking and running, and no more than 16 miles. So again, you need to think of a number that's no more than 16. Okay, no more than 16. Is 16 or 14, 12, 2. So that means this number needs to be all of those. So what symbol helps us get there? No more than is less than or equal to. So I've now used this piece. Eric must bike at least 4 miles. Well, biking is X, at least 4 miles, so he can bike 4 miles or more, so X must be greater than or equal to 4. And that last piece, and run no more than 2 miles. So running is Y, no more than 2. So we can run 2 or less, so Y is less than or equal to 2. For this we have 3 inequalities. Letter B, graph the system of inequalities. Again, keep in mind that we need slope-intercept form, so we'll need to modify the way that this one looks. This one is already in the form, and this one is review from way back this year and even last year of graphing. Where is X greater than or equal to 4? You know the answer to that. Take your time, think through it. I want you to finish this problem on your own. Think through it, and you can do it. Letter C, can Eric bike for 8.3 miles and run for 4 miles? So we only know the answer to that once you graph and shade these 3 inequalities. If this ordered pair, 8.3 miles and 4 miles, is in your solution where you shaded all the colors and wrote the S, then yes it is. So again, explain that in a nice sentence. I'm going to also help you with, if I were you, I would label your axes so it helps out a little bit. The x-axis, again, was talking about biking, so I might name this miles biking. And the y-axis, miles running. That may help you as you progress through this problem. Letter G is very similar to F. An economics class formed a company to sell school supplies. They would like to sell at least 20 notebooks and at least 50 pence per week. There are 2 inequalities hidden there. Their goal is to earn at least $60 per week. Don't miss out that here are prices over here. So again, for this we should have 3 inequalities. One that talks about how many notebooks, one that talks about how many pens, and one that brings it all back to talk about money. This one we do have to define the variables. So let x equal, let y equal, graph the system, and the shaded zone that is the solution needs the capital letter S. Good luck.